we want to rename certain expressions. Basically, we're wanting to simplify. And so we're going to start out with 11 times a y minus z minus 9. So this right here is telling me that I'm going to multiply the 11 times everything inside this parentheses. So I'm going to multiply, and I'm going to get 11 times a y minus, because I'm going to bring down that sign, 11 times a z minus 11 times the 9. Okay, well, 11 times y, all I can do is say 11y. Minus 11z, all I can do is say 11z. 11 times 9 is 99. Then I look and say, is there anything that I can combine? Well, this has a y. Neither of my other terms have y's. This has a z. Neither of my other terms have a z. So this is going to be my final answer. So whenever you have the distributive property, whenever you have things in parentheses, you're distributing into only the parentheses that is right next to that item. Let's look at another one where we have a g plus n in parentheses times a g plus n, let's see, plus a v. So we have 2 terms here times 3 terms. What this is saying is we're going to have to take and multiply this whole thing times every single term. Okay? So we can look at it as a g plus n times a g, and a g plus n times an n, and a g plus n times a v. And I'm doing this down because I'm kind of running out of room, is basically what's happening. Because then whenever I do that, I have to take these and multiply each item by the g, and each item by the n, and each item by the v. So let's start with this one. I would get a g times g plus a g times n. That would be this first one. So g times g plus a g times an n. Then I would have n times everything. So I would get g times an n plus an n times an n. And then I would do the same thing with the v. So I would get g times v plus an n times v. We want to simplify this as much as possible. So g times g is the same thing as g squared. Then we have a gn plus a gn. N times n is n squared plus a gv plus an nv. Then we look and say, is there anything that is common? Well, these two are the exact same. These both have v's, but they have other variables. So I can combine these two. I have 1 gn plus 1 gn. So that would give me a 2 gn. They're not multiplied, so I don't change their exponent. They're just added. And then everything else would stay the same. So I'd get g squared plus the 2gn plus an n squared plus a gv plus an nv. And this would be my final answer. Let's look at one more example, and that would be g times an n plus 1 minus a g. So in this case, I have a set where I've got multiplication here, and then I've got something that is subtracted. So what I have to be careful of is this g is only distributed into this parentheses. This minus g is just sitting out here by itself right now. So I'm going to take the g times the n and the g times the 1. So that'd be a 1g. And then I have this minus g sitting out here. And remember, in somewhere else we said that that's the same thing as a 1g, because I can put in a 1. 1 times g is still g, okay? And I did that because if you'll notice now, these two are like terms. I have a 1g and a 1g. So a positive 1g minus 1g, those actually subtract out, leaving me strictly with a gn. So you have to work each one of them slightly different, but you're still using the same distribution and addition, combining like terms processes for each one. So work a few of these and let me know if you have any questions.